Dear students, today we will derive Darcy-Weisbach equation for a turbulent flow in the pipe. So let's start. So today we'll derive Darcy-Weisbach equation. So here we are considering one pipe as shown in the figure. In that pipe, we divided this pipe into two sections, 1 1 and 2 1 2. This length is suppose L. This diameter is capital D. So pressure intensity, so we are considering one control volume enclosed between section 1 1 and section 2 2. So P1 P2 are the pressure intensity at the section 1 1 and 2 2. Similarly, V1 V2 are the velocities, respective velocities for section 1 1 and A2, section 2. L is the length of the pipe. This is the diameter of the pipe. P is the weighted perimeter. This is pi d. Here most important factor is frictional resistance. This frictional resistance is per unit weighted area per unit velocity. So this frictional resistance depends upon velocity. So velocity v to the power n. So where v is the average velocity of the flow, n is an index, is varying from 1.5 to 2. Depends on the material and nature of the pipe surface. For commercial pipe, n is equal to 2 for turbulent flow. For this case, we are considering n is equal to 2. So in that sense, average velocity is v square. That is for turbulent flow. And average velocity for laminar flow is only v. This frictional resistance depends upon, number one is average velocity, which is equal to v2 square. Then density of the fluid, then area of the surface in contact, then nature and material of the surface in contact. It is independent of pressure. So your F dash frictional resistance is independent of pressure. It depends upon velocity, density of the fluid, area of the surface, nature and material of the surface in contact. So initially, Prandtl's equation for the section 1 1 and the section 2 2. P1 rho g plus v square twice g plus Z1 is equal to P2 rho G V2 square twice C Z2 plus frictional loss. Since this pipe diameter is same for the section 1 1 and 2 2, this diameter is same, so discharge is same, so in that sense your Q1 and Q2 is equal, discharge is same. Since diameter is same, so area is same, area is equal to area A2. So as you know from here, A1 V1 is equal to A2 V2. Since A1 is equal to A2, so V1 is equal to V2. So you can neglect this. And this particular pipe is placed in a horizontal position, so Z1 is equal to Z2. So you can neglect these two portions also. So from this Bernoulli's equation you will get P1 P2 rho G is equal to HF. This is equation number 1. Now in this figure it is shown that the fluid is flowing from this direction, from left to right. So pressure exerted at section 1 is represented by V1, and pressure exerted in the opposite section 2 is P2 in this direction, and there will be another force, that is F1, which is frictional force. So what is frictional force? Frictional resistance force is equal to F dash. F dash is frictional resistance force per unit area per unit velocity. So into PL into V square. So PL means surface area. So PL represent surface area of the pipe of length L, and V you know, for we already discussed about it. In the turbulent flow, average velocity is given by V2 square. Similarly, pressure force in the section 1 1 and the section 2 2 is given by P1A minus P2A is equal to P2A, where this area is same. So if you observe all the forces, so summation of forces in x direction, you will get P1 A1 minus P2 A2 minus this F1 is equal to 0. Or you can write P1, or you can write P1 P2A is equal to F1, where F1 is small f dash PL V square. Now divide this equation P1 P2 by rho g. It is a F1 PL V square by rho g. Then from the equation 1, we already derived this one, this equation 1, you will get this is equal to SF. So SF is F dash PL V square A rho G. So your equation SF is F dash rho G into PA by A into L V square. A by P, that is area and perimeter, is called hydraulic mean depth or hydraulic radius. It is denoted by M. So P by A is equal to 1 by M. And 2G is F dash divided by rho G is non-dimensional quantity which is denoted by F. This F is called Darcy coefficient of friction. So your HF is equal to F dash rho G would be 1 by M into L V square. Here you multiply 2G, here also by 2G, rho G. So you can replace this by F. So SF is equal to this F into 1 by M into L V square 2G. Now for circular pipe, M is equal to A by P is equal to pi by 4D square divided by pi by D, which is equal to pi by 4. So if I put the value of M in this equation, you will get F into L D by 4 into V square twice Z. So it will be 4 FL V square D into twice Z, and this is called Darcy-Weisbach equation. Okay, there is another factor called friction factor. This is suppose F1, which is equal to 4F, that is 4 into coefficient of friction. And you can rearrange this Darcy equation. So this is F1 L V square D into twice D. So this is your friction factor, and this F is your coefficient of friction. So this is the derivation of Darcy-Weisbach equation. I hope you understand. Thank you. Stay safe.